Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 3, and in this lesson we will be talking about how to communicate from Arduino to other devices like to computer and to other Arduino board using serial communication. We also provide online training and assignment help, and we also do freelance based project based on embedded system, MATLAB, control system, etc. So if you have any such requirement or you want to contact us at, then you can visit us at www.jcbrolabs.org. Okay, so coming back to the main topic of our discussion, that is the serial communication. Okay, so just give me one sec. So we will be talking about serial communication. So first question should arise into your mind, what is the meaning of communication? So communication means whenever two persons are transferring the data from one point to another, or when two persons are talking, actually they are doing communication to each other. Similarly, in terms of the devices, suppose we have a device 1 here and we have another device here, device 2. So if they want to talk to each other, that means they want to send the data to this direction or they want to send the data to this direction, then this particular process is known as the communication. Okay, so communication means one time it is transmitting and at another time it is receiving, and when this device is transmitting it is receiving, and this device is transmitting, device 2 is transmitting, device 1 is receiving. Okay, so there are rules. They are like if we are talking in English, then there are certain rules to talk in English. Similarly, if device 1 and device 2 are talking to each other, then there are certain rules of communication, certain rules of data transfer. We can say data transfer or communication as well. And these particular rules are also known as the protocols. Okay, so there are certain protocols through which is known by device 1 and also known by device 2. Only then whatever data is being transmitted by device 1 can be understood by device 2. So it is like if these two devices don't know the protocol, it is like I know English and you know French, and if I am talking to you, you will not understand a little bit, and if you are talking to me, I will not understand a single bit. So if two persons are communicating, then the medium of the communication should be same to each other, so that both of them should know that particular medium of communication. Similarly, in terms of hardware or in terms of computers, two devices can understand whatever the other device is transmitting if the rules of the communication are understood by both of them. So there are several communication protocols available in computer language. If we talk about, like you have connected your Arduino through USB, so whatever data you are transmitting or downloading the data inside your microcontroller, that is transmitting through serial communication only. Okay, so other than that, there are several other communication protocol as well, like SPI interface, I2C, and several others. So in this video and this first, that is the simple communication protocol, that is known as the USART, Universal Synchronous Asynchronous Receiver Transmitter. So this particular protocol is used, and it is also known as the serial communication. So if I am using the term serial communication, then one question should arise in your mind, then what is parallel communication? So in parallel communication, between 2 points, suppose there is a point A and there is a point B. If we are want to transmit the 8 bit of data, then 8 different wires will be connected. Okay, so in this a bundle of 8 wires will be connected, so data will be transmitted over these 8 wires. So this is known as the parallel communication. Now in case of serial communication, we have from a transmitter or receiver, or we can say from one device to another device, we have a single wire. Okay, and for if it is a transmitter and it is a receiver, we have another single wire. So we are transmitting data over this single wire, and that means now we can't send parallelly, we will send one bit at a time. So if we are transmitting 8 bit of data, then we are transmitting 1 bit at a time to the devices. So that is why it is known as the serial communication, because we are transmitting the data serially, 1 bit at a time. So obviously when we are talking about serial communication, so there are certain terms which you should remember in terms of this serial communication, and very basic thing is known as the baud rate. Baud rate specify like how many bits, or it is also, we can say, data transfer rate, we can say it, data transfer rate. Data transfer rate. That means how many bits we are transmitting in 1 second. Okay, so generally there are two terms are there, baud rate and a bit rate. So don't never confuse between baud rate and bit rate. Baud rate specifies the number of level changes per second, and bit rate specifies the number of bits we are transmitting per second. So let's say if we are using a baud rate of QPSK, then within one level we are transmitting, let's say we are using 00011011. So in single level we are transmitting 2 bits, but in bit rate we will be transmitting 1 bit at a time. Okay, so don't confuse between baud rate and bit rate. Now in serial communication we talk about baud rate. So generally used baud rates are 2400, 4800 or 9600 and so on. So there are several baud rates which can be used for the transmitting the data. Then another thing is like data size, or we can say our data frame. So it is not like in communication we are transmitting the data over the channel, and actually it has to be packeted inside it has to be packeted, and then that particular packet is known as the frame. So in frame, actually in between it has a data, and then it has some start bit from where receiver and understand like data has been started, and it is known as the stop bit. After this bit it understand, okay, data has been stopped. And apart from in between this data packet, it could be 5 bit, 6 bit or 7 bit or 8 bit of data can be transmitted, or I think 9 bit of data can be transmitted over a channel. So it has to be specified prior to using the this particular communication. It has to be specified to the microcontroller, like in which mode and how many bits of data we are going to transmit over the channel. But you don't have to worry about all these things in Arduino. So now coming to Arduino, how can we define it? So in Arduino, most of the time it is already defined. We used 8 bit of data, 1 start bit, 1 stop bit. The only thing which we need to define in Arduino is the amount of the baud rate which we are going to use. So that is defined in void setup. So in void setup we will define like serial.begin. This is the command, and in which we define a 9600 baud rate in this single. Also we can also define several other parameters as well. Now in order to transmit the data over the channel, we have over the communication, we have two two commands, that is serial dot print, it is in small, and whatever the text string you want to transfer. So it should be remember, whatever we transmit over the channel, that is considered as a string. Okay, so whether you are transmitting a number or a string or a character or a hexadecimal number, everything will be as a string. And I hope you are also familiar with the Ascii codes. Those Ascii code actually are being transmitted over the channel. And this particular command is transmit a single line, transmit a line, or transmit a string, we can say, and don't, it actually append the data. And another one is the serial dot println. So we'll see the difference between these two. And then string, so it sends a line and character, or this particular character is also transmitted, so that the next line which is being transmitted, that comes after the first line. Okay, so this is this is two simple commands to transmit the data over the channel, and we will be writing this particular command inside void loop of Arduino. Now in this lesson, what we'll be doing, we will be having a Arduino Uno board here, and we will be transferring the data to the computer. Okay, so we will be transferring the data to the computer. And so once we are transferring the data to the computer, so there should be some program in the computer which should be monitoring the data coming at the serial port, and that particular program is known as the terminal or serial monitor. So this serial monitor program is available direct in Arduino IDE. Other than that, in previous Windows XP and in Windows system, there is another program also known as the terminal, which is displays you the whatever the content which is being received at the terminal serial. Okay, so this was the basic theory. Now let's come to the programming part, and let's write a program for it. Okay, so let's open and create a new one. Okay, in the meantime, let's start. Okay, you may visualizing the Arduino board connected, displayed here. Now this is here we will write our code, and prior to writing the code, just check whether everything is set. It is connected to the port. Yep. So now we will simply write simple, which we read till now. We will write serial dot begin, and let's say we type 9600, and then we will type like serial dot print. Let's see the difference between print and println. So remember, we are writing hello in print command, and then we are providing some delay in order to get the field, understand what is receiving, and then serial dot we are writing println to welcome to JCBRO, and then we will write print again ln. Okay, it has to be serial dot println. Okay, let's save this file. L03. Okay, so now upload it. Now it's uploading. Now you can open the serial monitor from this. Here it is serial monitor, just click on it. So now look, hello, welcome to JCBRO is appending to the hello. So this print command is not adding a next line, it is simply appending the next data to it, while this println is sending a command to the next line only. Now we have set the serial board at 9600 baud rate, and let's see if we change this baud rate to something else. So you will not receive anything. Okay, so this is what we were talking about. Like suppose device 1 is talking too fast, but device 1 is not receiving that fast. That means you will not get anything. So in order to understand the meaningful of data, device 1 and device 2 has to be operating at the same rate. That is in the case of 9600 baud rate. Okay, so this is also these are not good for testing, like to send some data. It is also good for let user understand like in which state current your microcontroller is. So suppose you are writing a big program, and if you want to put some checkpoints in between, so you can use this particular serial monitor to understand what actually happening or not. So let's test. Let's see what exactly I am trying to say. Let's say I have connected now 3 LEDs here. So as soon as one LED is turned on, I will be sending a data to the serial monitor, so that we can understand, okay, this particular thing is happening. Okay, so let's change our code a little bit. So in which like int red equals to, it is okay, blue LED is connected to pin number 9, and int blue equals to, blue is connected to 9 and red is connected to 8. Okay, so now from our previous one, we know first of all we need to set the mode. So red comma output and pin mode blue comma output, and then okay, let's set a test message. Hello, hello, welcome to JCBRO. Now in loop, let's write digital write red comma high, and then send the data serial println red LED is on, and then we can provide 1000 seconds of delay, and then let's change it to digital write blue comma high, and then serial dot print ln blue LED is on. Okay, now we can send we can provide a delay first, and then we can make them on off. Digital write red comma low, and then serial dot println red LED is off, and then digital write blue comma low. Okay, digital write, and let's say make a delay here. and make let's remove these two commands. Okay, now let's download it and okay, now uploading. Let's see. Okay, I have not put a delay here, so it is not visualizing it correctly. So red LED is on, blue. Okay, so when blue is off, red is on, so this is how we can make a program which indicates the state of the microcontroller and which can let us understand at which line our microcontroller is currently executing, or at which line our microcontroller is currently executing. Okay, so I hope you can see the camera here as well. Okay, so that was for this video. Again, we also provide online training on Arduino and MATLAB and LabVIEW and data science, Python, and we also do freelance based project on these specified topics. Okay, so if you have any such requirement, then you can contact us at www.gcbrolabs. So if you have any query, any suggestion, then you can let us know by commenting below this video. And you can also mail us at gcbrolabs@gmail.com. So I hope you enjoyed this video. That's it for this video. Thank you.